All right. Hello, everyone. Good afternoon, or good morning, or good evening. So, first, let's talk about the gridded data and special figures. Before we download our data, we need to understand the gridded data. What is the gridded data, and how to make a special figure or temporal figure? What the idea behind? Okay. Okay. Please communicate with me if you can't hear or if you have any question or you can share your ideas. Okay. So do you know how many dimensions of data can be in meteorology? Do you have any idea? Please share your idea. Hello.
Hello.
Yes.
Yes.
Yes. Please share.
Maybe 2 dimensions.
Mm-hmm. Any other? One people said 4 dimension as well. Any idea? All right. Our data till now, the data can be 4 dimensions, right? Okay. Here, this is a 3-dimensional data. So this is an example of TRIM. You know the tropical rainfall measuring mission, but it is stopped now. It was from NASA, right? TRIM data. This is the rainfall data. So I downloaded the data during Cyclone Sidor that crossed in Bangladesh in 2007. Okay. We can have 3-dimensional data. It can be rainfall or temperature or whatever, any data. But what is the idea about the map? We have a 3 dimension. In x-axis, we are showing the okay. So here in the x-axis we have the degrees longitude, right? This is the x, and we have a degrees latitude y. So what is the idea behind to plot this map and plot this figure? And map was produced by MATLAB software. We need to understand first. Okay, we have a 3-dimensional data. So what is the idea behind this? And how many dimensions here in this figure? How many dimensions in this figure?
3 dimensions.
No, in data we have a 3 dimensions, but finally in our map, how many dimensions? Yes,
2 x and y.
x and y. That's it. Like if you have the 4 dimensions of data, you can only plot, you can only figure out in 2 dimensions, like x and y. Did you get it? This is the idea behind the map, whatever it is, spatial map or temporal figure. Okay, we can only plot in 2 dimensions, like x and y. All right. So we have a 3 dimension like time, latitude, and longitude, right? We plot within lat and long, right? So what is the time? Our data within time dimension. Then we average the time dimension. Okay. I'm recording and I will share with on my YouTube channel. Don't worry. Okay. I'm recording. All right. So we average or sum or whatever. Then when we average or sum, we have only 2 dimensions, like latitude and longitude, and then we interpolate. Okay, I will talk the grid in the next slide. After next slide, I will talk about the gridded data. What is the grid? Then we interpolate the time dimension, we sum or average, then we just show with color. But in our map, we have only 2 dimensions. Did you get it?
Yes.
Okay, we can have the 4-dimensional data. Say for example, wind component. In wind, we can have time, the level, the latitude and longitude, right? But finally, we mapped with 2 dimensions. The same way in x-axis, the longitude, and y-axis is latitude, right? Then we can see besides the color bar, we can also see the direction, like wind bar, isn't it? So for wind, we first calculate the wind speed over time. We have the time. Then we select the label. What is the label? It can be from like 1000 and 1000 to 200 or 100, whatever. In this map, I use the wind speed. I calculate the wind speed meter per second at 850 SPA, the hectopascal label, right? And map was produced by NCL software. Whatever, you can use any software. It's not a big deal. So first we, same way, like three-dimensional data, we average the time, like wind speed, and then we plot it, okay, with any label. When we average the time and we take the label, finally we have only two dimensions, like latitude and longitude. Did you get it? In any data, any field, when you map something or you make a temporal plot or graphs or chart, whatever, you can only plot in two ways, x and y, all right? So then what is the direction? This is the wind direction. We have an option to calculate the wind speed and wind direction. Then in any software you can show, you can just like overlay whatever, or you just add the wind direction in the base map. Okay, you have the wind speed with the latitude and longitude, then wind direction we just overlay, we just place in the base map. Okay, this is the idea behind this. So what is the gridded data? Do you have any idea? What is gridded data? Rahmat Nabi. Any idea? What is gridded data?
Maybe the data that is presented in a grid format.
Mm-hmm. Any format, but these are global map, isn't it? These are global map. So in global map, we have the lat or long grid lines. Can you see the grid? The scientist created the grid lines, like grid box. Okay, the globally. And satellite that careful interpretation about the regular grid, and satellite get the data with over grid, like a box, then they interpolate. Did you get it? X is a longitude and Y is a latitude. That's why it's a gridded data in the grid box. Like when you have data, you can see the dimension like 144, say for example 74 latitude and 199 or 190 or 150 longitude. What does it mean? That this is a grid point, lat and long. Do you get it now? In numeric,
Yes, we can. Yes, we can hear you.
Yeah, when we collect the data, we can make in different format. We are not talking about the format, right? It can be in NetCDF. You can store your data in ASCII file or NetCDF format or binary format or etc., right? But the idea is the scientist made the global map in grids, the regular grids. So that's why we call the gridded data, okay, in every grid. So here you can see two maps. Okay, one is I use the gridded data, another is non-gridded data, like in meteorological station data. It was in an Excel file. Gridded data map was produced by NCL software, like I mapped with CAPE, like convective available potential energy, right? Joule per kg. So these are gridded data I just plotted in NCL. But when you have the non-gridded data, you don't have grid, like you just have some value. Say for example, this is a Bangladesh. Bangladesh has 34 meteorological stations, right? Maybe you have only 10 stations data. So how to cover the whole Bangladesh? That's why in ArcGIS we use IDW. Have you heard the name IDW? Hello? IDW, inverse distance widening. Did you hear the name? IDW. IDW. Inverse distance widening. Yeah.
Yes.
In RGS.
Yes.
Yeah. So we can interpolate like if we have the data here, right? Like 10, this is temperature 10 degrees centigrade. What will be the temperature in beside near the station or whatever? Then they calculate. There is an algorithm calculate the like nearest. Like say for example here 11 degrees centigrade or 10.5 degrees centigrade, etc. We just calculate the approximate. So when you have the non-graded data, you need to interpolate. There is a different interpolation, Kringing method, then IDW method. You have a bilinear method. Different. You have the method you need to use. But in graded data, inside the data, all it's automatically graded by satellite. Okay, satellite or the company like NASA, NOAA, or etc. They made it. Okay, and the same way, if you have the temporal data with time, or it is not the graded data, it's not related to a spatial map, like it's not related with lat and lon. You have the temporal data. In the meteorology, we have a time series data, isn't it? Whatever the temperature, rainfall, etc., it varies as a function of time, isn't it? So in this figure I adapted from my paper in 2020. This is SPI, you know the SPI and SPEI. This is drought monitoring index. Whatever, if you have the time, you can add the time in the x-axis. Then you can add your value. Okay, whatever it is, then you can plot in y. So we can only plot the x and y, like 2 dimension. All right. So from understanding the graded data and the data dimension, do you have a special figure? Do you have any question? Then we can go to the data source, data download option, etc. All right. If you are very new here, then it will take time to understand the map, graph. It will take time. Yeah. Even we have another class. We have a class in CDO. We'll use a lot of data in CDO, climate data processing. We'll show how to process this data, and we'll take the NCL class, MATLAB, etc. We'll figure out. We'll use the real data. Don't worry, we have the more classes. Do you have any idea? Do you have any comments or any questions from this slide? Hello. No?
No question.
No. All right. So now I will talk about the data downloading option. All right. So climate data download, I will show the free data sources and how to download them by Python code, right? Python and Internet Download Manager. I will show you how to. Okay. First, we can download the data by Internet Download Manager. We have different options, like we can use a wget by WebGate. We can use a Linux platform like Linux Terminal. We can use Python. We can use Internet Download Manager. So I will show you this link how to download through Internet Download Manager. It's very easy. Where you need to make a code like Python code. I will show you how to make code for IDA interim or RCA, NCP, etc. I will show you. Okay. So I have sent the file PPT. Okay. You have the Earth, NAS data, NASA Giovanni, and NCPD analysis data. If you open it, I have already opened it. Okay. So this is like GPM image final precipitation data. From this, if you open the NASA Giovanni, then search the GP image, the final data. This is global precipitation measurement data. It's a rainfall data. Okay, 0.1 degree, and this you will get it hourly data, hourly, daily, monthly. Okay, so in the default format is HDF. Okay, HDF, and the special coverage is global. Like the longitude is negative 180 to positive 180, and latitude is negative 90 to positive 90. Okay, Even the temporal cover is from 2000 to 2021. Okay, and every file has 30 megabyte. Okay, and temporal is monthly data. So by default is HDF, but we often use the NetCDF data. Okay, if you use the NetCDF data, it's easy to access, it's easy to customize in CDO, MATLAB, NCL, GRASS, etc., etc. Okay, okay, can you hear me? We are
Yes, yes, yes,
together.
we can.
Okay, okay.
Yes,
Response,
yes, yes.
response. Otherwise, I think you are sleeping or. Sorry, I'm kidding. Yeah, response. Yeah. All right. So we need to go here, subset. Can you see here subset or get data to get in NetCDA format? So when you click there, okay, there is an option to choose. Okay, then download option. If you go there, if you set the original, then you will get the HCDF format. Then you can get the subset is in NetCDF or ASCII file, or you can use GSDC subsetter to get the NetCDF format. Whatever you like. I use this one. Then you can select the time. Okay, you can put which time do you need. Then the special map, there is a special map by default, which area do you need to download. Okay, if you want to download for global, it will be so much data. Maybe you don't need the data for global, right? You just need data for Bangladesh or Tanzania or Nigeria, whatever. You just select your LAD and long. Okay, there. Like this is the format. First, you need to put the west part of the longitude. Okay, then the negative. This is the southern part of the latitude, 90 degree. Then positive. This is the eastern part of longitude. This is the north part. Okay, you just put there and select. I selected a very small area. Just show how to download. Okay. Then you need to select the variable. Then get the dimension. Then in the format you need to select which format you want, ASCII file or NetCDF. You just click on get data. I I gave you the link, right? I sent the PPT in WeChat. Then you will get the file. Just only one, maybe you have more file, 10 or 50 or 100 files. So how to download them? If you just download one by one, it will take more time. So it's best way to just download the link list. You just click, it will give you the text file. Okay, text file. I sent you the IDM file. You don't need to buy. Okay, IDM is not free, but I sent you in WeChat that's with crack. Okay, so I have already downloaded here. The file is there. Okay, I just downloaded. And how to open in IDM? I already opened it. I will show how to add in IDM and download. All right. So first go to download and go to options. Okay, don't worry, I will share the recording. Then just select save to. Where do you want to save? Okay, just browse and set. All right. In task, how to add this like text file in the IDM? So go to task, then you will find the import from the text file. When you select the text file, you can select the folder here. Okay, you can select the folder. Then where is your text file? Then just select and open. I already opened it. Okay, when you open it, just click on it and just resume. Okay, it's downloading. It's so fast. Achha. All right. Then this is the data. You just resume. Okay, but one thing to remember. If you don't have the ID, if you didn't register, you can't download from the NASA. Okay? That's why you need to register first. Open folder and you will see the data downloaded. Okay? Our data is here, is downloaded. But before you download, you need to register. Can you see my name here? Can you see? Hello?
I can't see.
Where?
Huh?
Yes, we can see it at top right.
Yeah, he is saying hi and
Yes, we can see.
yes. You need to register, okay? From NASA or ERA interim or NCP, whatever, you need to register, okay? You will do it at home. First register and follow my instruction. First you need to log in. When you log in IDM will pop up the username and password. You will just put username and password, and then save. Okay. Yes, sir. So you just put save there, then automatically IDM will download for you. All right. One people may question cubes that will show the way. Then when you know everything is the same way, you can download. Okay, don't worry. You need to know the process, right? I will go one by one. All right. So from this NASA Giovanni is finished. You just follow the instruction, or okay, let me send you the tutorial. I think I have it, or let me check. Yeah. Can you see the tutorial here? Can you see the screen?
Yes, yes.
Okay. Let me send the link. So besides the recording, there is also the YouTube video. Even you can follow this. There is a written. Okay. Let me send. Copy and send. Okay, I sent through chat box. Did you get it? Did you get it? Yeah.
Yes.
All right. So don't worry. Anyway, the National Geovenue or NCP reanalysis data, you can also need to begin fast, like register. When you register, then you select which data do you want to download. All right. Okay. You just use the IDM. Then another option, like NCEP reanalysis data, you can download the data directly here, or just download file, or you may plot. Okay, there is option. Say for example, if I don't want to download files, maybe I don't know the programming or etc. etc. I just want to get the plot. Then click here, plot. It's just creating plot. Can you see my screen? Hello?
Yes.
Okay, then you need to put, okay, yeah, temperature, you need to select which level do you want to, the time range, etc., etc., etc. Just then you can plot this and download the subset defined by option. So you can just define and then you can download the figure. Instead of data, you can also download the plot. I have sent the link in a PPT. Then if you want to use like climate indices, whatever I said, the teleconnection or atmospheric or ocean time series data, say for example the ENSO, NAO, and North Atlantic Oscillation, NINO, etc., you just go there, this link I send there, and you need to download. Say for example the NAO, you need to download from the Climate Prediction Center. There is a link. Okay, you just follow, and there is a in details how to download. Don't worry. So this is the data you can download directly by IDM. All right. Okay. But there are some website, the data provider. You need to use the Python code or Carl or etc. etc. or Linux wget. Say for example like IDA interim. I hope you know this website, right? IDA interim. or ECMWF. Okay, let me open it. Okay. You also need to register for first. All right. First, register. This is an instruction because we have the another class. I talked to Matthew. I need the 2 classes. Okay. First, you need to register. Okay. And then we'll use the Anaconda for the Python code. We'll use the Anaconda. So I already sent the link in WeChat. I'm sending here also. Okay. You need to install the Anaconda. Okay. Follow this video and install the Anaconda. Okay. And you need to register. You also need to follow something. All right. Let me see. Yeah. Video not. Then install the API key. Okay. So this is very technical. I will show the next class because this will be more technical. You need to register. You need to install the Anaconda. Then I will show you how to install the API. Then install the Python client API in Anaconda with pip. Then we will download the data from ERA interim with the Python code. Okay, and I already sent some code here like cave.python. So I will describe what is the code inside it. Okay, so what does it mean? You need to send something here. Okay, you will not get the code like this in the website, but I made something for you. I already customized. Okay, so I will describe where you need to change. Okay, then we can use this code to download our data. Okay, it will be super cool. Then we will also download the data from NCP, climate forecast system data. Okay, it will be Python code like this. Okay, this is a long you need to also register there. In every website, you need to register first. You need to register, finish your registration, then install the Anaconda, and in the next class, I will show one by one because this is very technical. If you missed one thing, then when you use your own data, it will give you pain. Okay, so you need to follow one by one. Don't rush. Then we can download the Python script, Jupyter notebook, or CSS global, etc., but we use the Python code, and I will show you how to download with the Python code in the next class. Okay, and thank you for tonight. Any question? And for the data structure and etc., it will be better on more on the CDO, like in climate data processing. Okay, the CDO, the climate data operator, we call the CDO, will show how to process the data. We'll talk more about the data structure, etc. Okay, any question?
A question.
Yes.
Could we have a script for downloading the forecast data?
Yeah,
Not
this is
the
a forecasting
historical.
data. This is like here. This is a forecasting.
Forecast data for downscaling, for example, from ECMW, something like that.
Yeah, for the ECMW, we'll show the next class how to download from the ECMW. You need to know the process. Then you select the which data do you want to download. There's a lot of data. Did you get it? I will show how to download from ECMFWP. So you can just which data do you want to download. And for the NCFE, the focus data, I will show how to download. There is a lot of parameters, a lot of variables. It's up to you, but you need to know the process. When you install the Anaconda, you know how to download with the Python code, how to modify the Python code. Then any data you can download. Okay.
Okay. So when is the next class?
Yeah, next class. Even you
When?
from yeah.
When is the next class?
Okay, the Matthew, the president of IMSA will notify you. All right.
Okay.
Yeah, so even here you can see the data from subset, Giovanni. Yeah, there is another option with, you can use the Linux. Okay, there is a different option, but I don't suggest the Linux. If you download through the Linux terminal, it takes long time. Okay, it's better to download with Python code. It's better. Even I will show you how to download data through the Linux terminal, like use the wget or webget. Okay, the next class. This is a technical. Matthew, can you hear me?
Yes, I can hear you.
So I want to take another class because the next class will be very technical and some people are very new. Okay? Yeah.
Yes.
Yeah.
Oh, okay. So,
yeah, don't rush.
Okay, so I see like there is Anaconda. They need to install Anaconda first before they come to the next class, yeah?
Yes, Anaconda. Because in Anaconda, everything is there for Python. Did you get it? So you don't need to install other dependencies. So in Anaconda, everything is there. It's better. Okay?
Oh, okay.
Anaconda, first thing. Second thing is everyone need to register.
Like which sites need to be registered? Only ECMWF or other sites, all of them?
Other side also like ECMWF, then the NASA Giovanni, yeah, for NCP climate forecast. I sent the link. So in there, everyone need to register. Otherwise, you can't download because its data is free. So who is downloading?
Oh, okay.
Yeah.
Noted.
That's why I want to skip the class for the next time. By the time they will understand and they will register, they will install, etc., etc. And they may ask any question if they have encounter. Okay. Okay. Thank you for today's class. I want to finish. And thank you so much, Matthew. I want to finish now. Okay.
Okay, yeah. So thank you very much, our facilitator, Mr. Gerald.
Okay.
And all the participants. So this is just the beginning, and the next class will be on Wednesday. I think now this one will be